Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine Podcast Radio. You're about to listen to a new Redefining Technology podcast. Standing on 2 feet, having dexterous hands, developing a language that allows us to communicate, and the ability to understand abstract concepts. These are all part of the equation of humanity. Still, it is the capacity to create tools and advance the technology that has allowed us to thrive on this planet, and maybe on others. Knowledge is power, now more than ever. Blue Lava is the first business platform for CISOs to manage their security program. Blue Lava guides security leaders to effectively measure, optimize, and communicate their security program with confidence and ease in one platform. Learn more at bluelava.net.
Devo unlocks the full value of machine data for the world's most instrumented enterprises. The Devo Data Analytics Platform addresses the explosion in volume of machine data and the crushing demands of algorithms and automation. Learn more at devo.com.
CrowdSec, the collaborative and open source cybersecurity solution. Analyze behaviors, respond to attacks, and share signals across the community for free. Let's make the internet safer together. Learn more at crowdsec.net.
Marco,
Sean.
do you remember that time?
Yeah, of course. I think about it all the time.
It's like it was yesterday.
Yeah, or it feels like it was tomorrow.
Exactly. I'm thinking of the time where we didn't have, and maybe not everybody has it, but information about our health at our fingertips. Right?
Yeah.
So we had to either just kind of go with the flow and hope everything was good. No signals or signs for something that may be happening to us that needs attention. And we go to our annual checkups instead, right? And do a panel of things, and hopefully if something bad's happening, we find out. But in between that time, we have a year of who knows what happening to our bodies, right? Hopefully nothing bad, but sometimes there are things happening. Those times have changed. We have smart watches, we have smart sensors, we have other types of technology that help us as consumers, which is good. I don't have as much visibility into what's going on in the doctor's office, the broader care ecosystem, the hospital systems. And I'm just wondering how well technology is working in that realm connected to us as consumers of our own.
And I agree with all you said. That's why I didn't interrupt you, as I often do. Being Italian, I like to just step in.
That's right.
It's in redefining technology, and we say, it's all about how technology is serving our humanity and make things better. I don't think there is a better topic to talk about than healthcare. So I'm very excited about this conversation, which is specific on a certain area of care, but we can probably start with a little bit of an overview of how advanced technology is actually making our life probably a little bit healthier. At least I'm hoping so. So I have a lot of questions, Sean, and I hope you brought a good person that I can ask.
I think we have a fantastic guest with us. Well, time will tell, Marco. No, I'm excited for this, and we're excited to have Konrad Wagstyl on. Konrad, thanks for joining us.
Thanks for having me. Really excited to be on this.
And hopefully I pronounced your surname correctly there, as you hail to us from the UK and bringing your knowledge there. Perhaps a brief word about some of the work that you're doing and your role in this particular topic of technology in healthcare.
Sure. So I'm a researcher at University College London, and I work on applying AI to medical problems. And kind of just as a step back, where AI is at the moment in healthcare, we've obviously over the last 20, 30 years had this massive increase in measurement. You described it in terms of smartwatches and smartphones, but similar developments or even more impressive have been going on inside hospitals with new scanners, high field scans for your brain. You can see millimeter scale changes in brain structure that couldn't have been imaginable 10, 15 years ago. And those kind of advances are happening in all the fields of medicine. I'd say that alongside that, the research field has got really advanced in the kind of way those images are analyzed and diagnosed. So they have all these automated helper systems. If you have a ECG on your heart, there's a little automated AI system in the recording that will tell you whether the rhythm looks abnormal, for example. On the research side, with this boom in AI, there have been a few kind of key examples where there's been a lot of development. Things like diagnosing skin cancers or chest X-rays. These are kind of the big topics that lots of AI research has been going on to. And there are some other examples of big advances which have potentially massive impact. There's kind of two things blocking that translation from the way I see it. One is when you have something that works, how do you get doctors to start using it? How do you find the right way to incorporate that into someone's visit to the clinic? And then the other issue that is a big one for AI is identifying the right kinds of problems that AI really could help with. So things where either there's millions of scans and humans can't possibly review them all, that's perfect for AI. And the other side of it might be things that humans can't see and an AI might be able to diagnose, so beyond the expert. I work on a specific kind of epilepsy diagnosis from MRI scans, and that is more of a case of where experts can't see what's wrong, and maybe AI can find something that the humans can't find. So I'll give you a bit of background about the epilepsy problem and where we are at the moment and where we're going to be heading with this in the next few years. So I'll start with one patient, one child. In fact, he's a 3-year-old boy who suddenly starts developing epilepsy. He was completely normal before, and suddenly he has 20 to 30 seizures a day. He goes, obviously his parents are really worried. They take him to see a neurologist. The neurologist orders a brain scan and starts them on an anti-seizure medication, and nothing changes. It doesn't work. They try another one, nothing happens. Then eventually this can go on 2, 3, 4 medications, nothing's changing. So they send them to a specialist centre, and I work at Great Ormond Street Hospital, which is the big children's hospital in London. And there they get reviewed by a team of experts, so people who are experts on epilepsy scans or experts on taking the history from the patient, finding out what subtle features might tell them what's going on. And at this meeting with 10 or 15 experts, they review the MRI and they see a very subtle abnormality on the MRI scan. And this abnormality is the disease that I really focus on, which is called focal cortical dysplasia. It causes epilepsy, but it's got a key feature, which is that if they have surgery, they can remove this abnormality and the seizures are cured. No more medications, no more epilepsy. And this is for this 3-year-old boy, this is what happened. They had the neurosurgery at Great Ormond Street and the seizures stopped. So the kind of key AI question there that we are aiming at is that the first time this MRI scan was reviewed, it was missed. And with these patients, it's very common that it's missed. And so if an AI algorithm can look at that scan and say, you have this abnormality here, you can skip all those trials of drugs which just won't work, and you can skip the years of delay to having surgery and potentially make a huge difference in these children's lives, not having 30 seizures a day for several years, getting them to surgery much quicker and curing their epilepsy much quicker.
So many questions. Thanks for that story, Konrad. And I think that helps us and our listeners kind of visualize what's going on here and put some context to it. The first thing I'm wondering is, so kind of to your point, the first scan didn't catch it. I don't know if that was just because it was looked at by a human and not AI, and then the next one it was looked at by AI. Is it purely that AI looked at it, or was it that AI looked at it compared to a previous scan? And I'm just wondering what's possible without without certain sets of baseline information, or could we use other patients' baselines and compare our own a single new scan to another baseline, or what's that picture look like? What do we need for this AI to actually function?
That's a great question. So just to clarify one thing, that this child was before we had this technology. What found it was a team of radiologists looking at the scan many years after the original scan. To your second question, that's exactly how we deal with it. So your question was, how do you teach the AI to learn what's normal and what looks abnormal? And that's really where our research is at. Firstly, you need a lot of data. You need lots of examples of scans. And for this, we have teamed up with 23 hospitals around the world. They have shared examples of healthy brains, so no epilepsy, and examples of patients where they have this condition, this brain abnormality. And we essentially train our computer algorithm to recognize which bits look like that focal cortical dysplasia, this abnormality, and which bits look normal. And we have 1,000 of these examples now. And that's really what's made a big difference in this field, being able to identify these abnormalities on scans from different scanners around the world.
So the other thing I'm wondering here is this particular patient was experiencing the symptoms of that abnormality. I'm just wondering, is it possible to find other signals or signs before the actual real issue of the seizures come into play, such that the uncomfortable moments and the medical issues that come with the seizures can be prevented in the first place?
That's a great question. So this abnormality starts when the fetus is still developing. So it's pre-birth. Something goes wrong in the way that the brain is developing. So it is there from birth. And if you scanned everyone in the population and you got them all expertly reviewed, or with a perfect AI system to pick these out, then you might be able to identify people who are very likely to end up having this horrible seizures. I think that it would be quite forward to then start operating before they have seizures. But I think you could definitely identify a set of people who are very high risk to have these seizures. And the second they do, then they go into a different pathway. So high risk individuals, yes. And ideally, you could identify them before any of this traumatic experience starts.
Well, I let Sean ask the questions because you always have great questions. So I have more than a question, like a thought. And we talk a lot about cybersecurity, right? We talk about privacy in our other shows and in this show, and how sometimes there are resistance, maybe cultural changes that need to happen in a specific industry or category of professionals that could slow down the evolution of technology, or maybe the patients are not so receptive because maybe they don't want to share their data. Maybe there is the level of privacy. Maybe they don't understand that if there is a choice between getting better or not, maybe it's better, I don't know, sometimes I think better to lose a little bit of privacy, but actually resolve a problem. So it's much more philosophical, but I'm wondering, you as a researcher, I'm sure you're all about the new technology, but do you feel like the healthcare industry is embracing technology as fast as it should to make it even better, sharing information? So is it culture, or is it's a structural issue that things need to change in order to become better and faster?
Those are really great points, Marco. What are the barriers to getting this happening faster?
Yes.
And you perfectly identify that getting large data sets is essential for machine learning. On the one hand, I think that if we were able to share more data more freely, there would be faster advances. But as you also point out, there is this kind of wariness about just completely open data for good reason. In many societies, it's not good to completely share your data because you don't know how it's going to be used. So I think the medical profession is quite skeptical about sharing data, but it's changing. There are systems being put in place, either sharing data or finding ways of doing this kind of research without sharing the data. This idea of federated learning, where the technology moves around and the data doesn't move. And then on the other side, you were talking about engaging with patients and understanding their perspective on this. Would they like their data to be shared or not? And it's something that certainly within our research, we really prioritize. We're actually this week, we're organizing a workshop with parents of children with these types of epilepsies to understand how do they feel about their data being shared for these kinds of purposes? How would they feel about AI being used to diagnose their children? I think in the scenario that we're talking about here, where it's very severe epilepsy, 20 to 30 seizures a day and nothing is working, people, doctors, children and parents are all so desperate to have an answer, very understandably, that the kind of openness to sharing their data in order to find these abnormalities is quite high. And I think there's probably a spectrum where there are other conditions where people would feel a bit more concerned about whether their data is being shared. And I think in each example, it's really important that the people doing the research engage with the people whose data is being used for this purpose, that the patients who you really want their buy-in, their kind of agreement to have their data used in this way.
And Konrad, talk to me about the importance of context here with this information, because a scan on its own, let's assume we've redacted all the personal information out of there, and perhaps we also have to redact some of the adjacent medical data as well, so somebody can't be identified. But is it that the work you're doing with the AI for this particular case requires some context to really pinpoint this is a problem? Because I'm just wondering, knowing whether or not a patient has experienced an epileptic moment would make a difference in how you read that scan. Whether they're on medication might influence how you read that scan and decide to take some action or not. And so I'm wondering, specific to epilepsy or perhaps even broader picture, how important is the contextual presence of other information to help really see things forward?
That's a great point. And you've kind of struck on a real key issue about this, which is that epilepsy is not it's not a brain structure thing, it's a seizure thing, right? So when the doctors are looking at this, they have a multidisciplinary team. Some people are experts on looking at the scans. Some people use other kinds of contextual information, like the type of seizures they're having. That can tell you, if the seizure starts with a hand movement, that tells you something about where the seizure is coming from. Again, what medications they've been on, other scans that might be informative, all these things. But when you're planning or when you're discussing these patients, all these experts and all these different tests come together. And as you point out, and to be honest, an AI that's just looking on the MRI scan can't possibly know for certain that the epilepsy is coming from this area. You wouldn't just trust that. You'd want some kind of electric measurement as well. So you kind of have two options. One, which is the current system that we have, is that we look at the MRI scan, we find some areas that look a little bit funny, maybe one, maybe two. This then gets presented back to that whole team and they can say, well, it's definitely not this area because this is not where the seizures are coming from. But this other area is very much in keeping. The hand moved and there's an abnormality in the hand area. Actually, that makes a lot of sense to us. So in the current scenario, we definitely need the doctors to kind of integrate that information, the context as you described it. I think the next step, if we're talking about the future, would be to start exposing the AI to these different types of different modalities, different types of contextual information that would enable them to carry out these calculations on their own and only put forward the area that really looks like it's causing the seizures.
So you're in London and, in Europe, UK, we're in the United States. I'm thinking, how can we exchange this learning, this technique to other countries that maybe don't have advanced research like this? I mean, I always make you think like, the first world country, third world country. I hate that division, but it's a matter of fact. And then hopefully with the globalization, things are getting better. So share of information. And I'm also assuming that the more data you bring in, you always have a better machine learning system. So how is the relationship in terms of the community and using and scaling these results and these technologies?
Yeah, that's a really key question. So part of that we address through all our, so your questions about how, I mean, for countries that have MRI scanners, how can they analyze them? How can they use this technology when they might not have the same level of expertise? And there's a separate question about countries that don't have MRI scanners, which is a very expensive technology. So I think that the epilepsy community, and I'm sure this is true in other medical fields, is getting quite good at recognizing this as a problem and integrating. And we think it's a real priority in our research. So one of the key things for us is that we make all our code and trained algorithms open. So anyone can download it and run it on their own site. It has this caveat that it needs to be assessed by a doctor, but it really is openly available to anyone. Additionally, our multi-center study, so we don't just use data from London, we use data from 23 hospitals around the world. And those vary from cutting edge hospitals like the ones in London or the Cleveland Clinic in America, to countries with less well-funded research and technology and medicine. These include countries in South America. We have sites in Asia. So from that point of view, if they have a scanner and the capability to run the software, they are able to use this technology. And we're really kind of keen on helping sites to use it. The second part of that, which is that if they don't have an MRI scanner, this is completely currently not applicable. There's no way of looking inside the skull to find these abnormalities. And this is not research I'm working on, but there's a big development of these portable MRI scanners that are much cheaper. They're portable, so they can be moved from place to place. And I think they will have a huge impact in countries that currently can't afford these £1 million scanners, particularly in Africa. So we have 5 continents as part of our study, and we don't have any patients from Africa, mostly because there aren't very many MRI scanners. And so I feel like these kind of lower cost MRI developments will be a fantastic benefit to those countries.
And I know you're not working on that specific the technology for the portable scanner, but is there a certain level of data or amount of data or detail in the data that's required for the AI to work? Is there enough in the portable scanner to either make an identification, I guess is the right word, or perhaps extrapolate it enough to say this is the direction things might be going?
Yeah, that's a good point. So, if you have the scanners are kind of measured in Tesla field strength, it's the power of the scanner, and hospitals currently have 1.5 or 3, and then the really cutting edge hospitals have 7. And we've seen that as you go through these increasing power, you see more detail, and more detail means you're more likely to pick up these really subtle abnormalities. So on the one hand, going for low field MRI might not pick up these most subtle ones, but there's a real spectrum, and there's a whole set of them that are much more visible. And with these low field MRI scanners, I'm pretty sure I've seen some of the images that come out of them. And I think that the combination of having these images and having better AI to kind of improve the image resolution and contrast will enable a percentage of them to be detected even with these lower field MRI scanners.
Nice. So I'm gonna ask a question that's not specific to this particular research, and I'm interested in your thoughts on this because, kind of to Marco's point earlier, sharing data for the benefit of the individual, benefit of society, is important. Your group has reached an agreement to collect information from these different hospitals to do this research, and I'm just wondering, how do you see things going with that in terms of, okay, you now have this data set, and perhaps as you're evaluating it for epileptic anomalies and other identifications, you see something else that is interesting but not related specifically to what you're looking at. Do you think it's okay to start to analyze that data in a different way, or are you limited to what you've requested in terms of research? Because I'm just thinking, there's all this data. Should we just put it all together and let anybody analyze it in any way possible? But then things can go really strange in that respect, as an extreme in the other direction. So I don't know, your thoughts on this, a little bit philosophical there.
I mean, it's both philosophical but also very relevant to our day-to-day working. We have created a large data set of 1,000 subjects with a relatively rare condition. It's really valuable, and it would be a shame to kind of restrict the way that it can be used to this one case, given the amount of time and effort everyone's put into it. With the move towards open science, there are data sets out there that are completely open, not for this particular condition, but for other conditions. So particularly brain imaging has nice large open data sets that people can ask questions. Because we're using clinical data, it's a little bit more tricky about who you can share it and how you can share it. It is possible for us to share our data to other researchers. And in fact, other people have said, I'm interested in this aspect of the epilepsy. I would like to use your data for this purpose. And we have a system where all the 23 sites just say, yes, I'm in, no, I'm not. And if they sign up, then we can pass the data on for that other group to then reanalyze it. And there've been 2 or 3 other groups that have been looking at this data for different questions. So it's kind of massively added value to the data set to be able to ask these other types of questions that we wouldn't have even thought to ask ourselves. Yeah.
Well, I find like this very exciting when you look at the future, because you're talking about exchanging informations between different disciplines of healthcare. And let's be honest, we are a complex mechanism. It's not just like, I just fix bicycles.
One on and off switch. That's all we have.
Exactly. So I know, even if we look at, I'm just thinking long COVID now, we don't really know yet what causes. So I feel like there is different disciplines inside the medical profession that needs to come together. And I'm just imagine this enormous computer, maybe shown a mainframe, old school, where you just put, all the information and then it come out with the answer, which may be 42 or maybe not. But let's look at the future with this in mind. I think you said something like open science project. I'm thinking open source. I'm thinking like crowd search, crowd collaboration. Do you think we are, as a community, in the right path, and also as a government, financing and moving forward with this? Like, I mean, I don't want to give false hope of a utopia, but it seems to me that we're making really big steps. So how do you see the future of treating the kind of issues that you're dealing with, but also healthcare in general with health tech?
Yeah, that's a great point. And I think that no one really knows where the next great idea is going to come from. And this kind of open science really kind of powers that, the possibility that someone who doesn't have access to huge amounts of research resources is still able to access, these and ask really interesting questions about, our health and our biology. I think the field is definitely moving in that direction. There are some amazing programs. In the UK, there's this thing called the Biobank, where they've scanned hundreds of thousands of people, linked it to their health records, sequence their DNA, and that you can gain access to that data set and analyze it. I think there's companies accessing data and a lot of researchers accessing the data. I think the same is going to be true for epilepsy, that, we've managed to create this great data set, and that's fantastic. But, a computer scientist might have a really great idea that's better than anything we've done. And if they can access the data set, they can, provide a tool. And actually, that's really the aim of it, to create the best tools for patients. It's been in the news in the last week, though, that there's slight concerns with these things because, for instance, 500,000 people from the UK have all their biological and genetic and healthcare records now basically available for anyone in the world to access. And it's made with the idea that people are doing this for beneficial reasons, but you don't really have a control over what someone's going to do with the data once they've got it. And there are concerns now about kind of public, national security risks associated with this. So I think it is absolutely the way to go, and I think some of the caution around the way it's done is healthy. But I think we're headed that way: bigger, larger, more open data sets.
Yeah, and it's always a fine line, a delicate balance of.
There's always people breaking the rules. Can we just get
well, there are no rules to start, right? And then we put rules in place because somebody does something stupid, and then the rules are broken by those who don't care about the rules anyway. And years ago, I've heard stories of certain nations collecting DNA information to use for their benefit, perhaps militarily and politically.
It wasn't years ago. I read this like maybe 3 weeks ago. I'm sure it's still. I'm not going to name the country, but I think everybody can guess it anyway.
So there's always that, but then you have to ask the question: okay, if one can save their son from serious epileptic seizures, and help them live a normal life, isn't that worth it? And perhaps identify that child's children might be prone to it and help them avoid it in the future. I don't know, the value there is immense in that respect. So hopefully there are systems to help guard against the bad actors. But I think that the technology used in the right way, there's no question it's a good thing, of course.
I couldn't agree more. I think there's a huge amount of potential benefit for many, many people. And if it's just done in the right way, with the right, precautions, the limitless opportunities.
Look, I want to close this, and I know, Sean, you're going to make the final call to resources and everything. But my thought that it just came in my mind is when I was reading about, if you don't take risk, we wouldn't not advance in technology ever. People didn't want cars. They just wanted, as Ford used to say, fastest horses. But then
horses on cocaine. Just
exactly. That could be that. I don't know if that would have probably caused a lot of accident anyway. But my point is, there's always resistance. There's always fear for new technology. Electricity, I can bring a gazillion. And now there is this fear that is all justified, definitely for privacy. But I think, and eventually you got to take the leap and hope that technology will actually serve humanity in the long run, even if there are some hiccups on the way.
I agree. I think that the car's a great example because, once people were driving cars, there's no comparison to a horse. And I think that will be the case with AI as well. Once you're getting diagnosed in 10 seconds, perfectly accurately with, faster than any human was able to do before, much more efficiently, cheaper, the argument will have already made itself. You won't need to persuade people.
Yeah. And there's horsepowers in the car anyway, so.
We keep the horse there. Well, this has been fascinating, and I love having these kinds of conversations where I know nothing and know that there's something cool happening. And I'm glad to hear this story and to have this conversation with you, Konrad, and appreciate you doing the research and bringing this story to life. And for those listening, we'll include links to Konrad's social handles so you can connect with him there, wherever he chooses, and any research he wants to share or other articles or resources that he thinks would help people take the next step in their own research to learn more about this topic. We'll include those in the show notes. And with that, I want to thank Konrad for joining us here on Redefining Technology, and Marco for having a great convo, and for everybody listening. Stay tuned for more as we connect technology to the way we live, and hopefully the way we live to drive new advances in technology as well. So thanks, everybody.
CrowdSec, the collaborative and open source cybersecurity solution. Analyze behaviors, respond to attacks, and share signals across the community for free. Let's make the internet safer together. Learn more at crowdsec.net.
Devo unlocks the full value of machine data for the world's most instrumented enterprises. The Devo Data Analytics Platform addresses the explosion in volume of machine data and the crushing demands of algorithms and automation. Learn more at devo.com.
Blue Lava is the first business platform for CISOs to manage their security program. Blue Lava guides security leaders to effectively measure, optimize, and communicate their security program with confidence and ease in one platform. Learn more at bluelava.net. We hope you enjoyed this episode of Redefining Technology podcast. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.